Hello, everyone.
Hello, everyone.
Can we give a little bit of space to the virtual presenters? Thank you. Thank you so much. Okay, so Yongkwan and Fei, thank you for participating. I believe that it is a very late time for you guys. And then, there is six physical presenters and 2 virtual presenters at the stage. So let's have about 10 or 15 minutes of panel discussion. So before starting the panel discussion, I'd like to kick off with one quick question. So in this session, we learned about a novel sensing hardware or novel sensing technique, and which eventually support a novel sensing application. So the question that I'd like to ask to all of the presenters is that what else application or sensing technique or your sensing hardware might be able to support? So there's a reason that for this question, 2 reasons. One is that if you, as a researcher, and then you came up with a great sensing technique which requires, for example, some new sensing hardware, and then it is an awesome advance in terms of research and science. But if you would like to commercialize it, and then you need to talk to the production team, and then you need to persuade the production team that adding this particular sensing hardware could open up like a multi-million-dollar business, or at least dozens of single-million-dollar businesses, right? So there is one question. There is one reason for hopefully you could find some other applications, some more applications other than your original application. And the second reason is that actually, I believe that it is one of the cornerstone of the driving force that leads to the success of the ubiquitous computing. So if you read one of the the early vision paper, and then one of the key driving force at the time was that the appropriation, right? So a single-purpose hardware or infrastructure is appropriated to support multiple applications or scenarios, which eventually, they open up the potential and the applicability and comprehensiveness of the infrastructure, devices, hardware, and so on. So anyway, those are some the rationales behind my question. So if you have any ideas about some what else application that your sensing technique or sensing hardware could be able to could support, and could be not necessarily for your own work, but you can maybe share the ideas that inspired you from other presenters' presentations.
Yeah. Thank you. Yeah. So we've at least for my project, we've done the NSF I-code thing. So a lot of discussions already. So that's why maybe I can answer first. So yeah, as also highlighted by Professor Doon, right? I feel for force sensors, especially doing the on-body sensing, even with our work, there would be a lot of unknowns, and these things might delay commercialization. I feel wherever the surface is flat, the sensors really work well, whatever we have been developing. And I would like to perhaps pursue a lot of ubiquitous weighing machines as an application, perhaps this gadget which we have developed becomes readable with smartphones, then you can perhaps stick it below your bottle, read the water's weight, and you get a notification that, okay, yeah, you need to fill up your bottle or something. Or maybe carry the sticker around, so if you have, if you are checking in your luggage, you don't need to rely, you can just stick the thing on your luggage and weigh. So there could be a lot of applications if we start looking where things are simpler, and those would be the first to, I think, get commercialized, and we are doing some of it as a follow-up work of our own.
Just as a counterpoint to that, I think we've seen a lot of that in wearables, where we're aiming for something wonderful, like maybe a clinical result or something, and then we discover it's way harder than you think it's going to be to actually get that kind of accuracy in real world environments, and then we back off it towards something like step counting, or something that's like a little bit more accessible. So, you know, I totally agree. Like that's sort of where the commercial marketplace pushes us. But as researchers, I think we should always be, you know, trying to keep that focus on those really hard parts of the problem that would enable something, you know, even more exciting or different or valuable to a different community.
That was wonderful, contrasting discussion. So I really appreciate it.
So I think for my experience, because I'm working on spectroscopy, so in this work, I applied the spectroscopy for baby foods nutrient detection, but in my opinion, spectroscopy is not limited to this application. Actually, as I mentioned in my presentation, in the discussion and the future works, our system can be extended to other food content detection, such as liquid content detection. For example, you can detect the sugar content in the beverage, or you can use it for food adulteration detection. You can detect whether alcohol is adulterated or not. So I think our work has great potential to be deployed for future applications.
In terms of my work, I have explained before. The mouse gestures has a lot of applications in, for example, VR and AR systems and also accessibility systems. And for EchoNotes, it is really easy or just to integrate the system with the VR AR headset. And our gestures are more focused on interface control or gaming functions. So I think that's a great potential view for commercialization, but I also think it is cool to explore a wider range of possible mouse gestures.
Well, for my system, actually all the devices in my papers are commercial devices, so there is no additional hardware cost for customers. But for producers, well, it's interesting. For the air computing community, there is a great opportunity because yesterday I met people from Nokia Bell Lab, and they have produced some commercial products that integrates the air computing techniques to their earphones, and they may begin to commercialize it. So I think the producers may have begun to use our techniques.
Thank you for sharing your thoughts. Is there any comments from the virtual presenters?
Yes. So I definitely agree with the point you just mentioned. Practicality is very important. So for our work, Microcam, we have always actually considered the commercializing in our research, which is also why we introduced the continuous learning to solve the problem of robustness and generalization. So however, there is still some limitation. For example, the computation power of mobile phone is still inefficient. So in current version, we just use the deep learning neural network, but deploy it in the cloud. So in the future, if as the development of the computational of mobile phone, we try to imagine that maybe we can deploy the deep learning network and do some computational locally on the mobile phone. So yeah, that's my point.
In terms of my work, I feel that with the deployment of the IoT, the use of wireless sensing is become more and more useful because it can work in no loss situation compared to the camera-based situation. But at present, I think a core problem is how to achieve robust protection of the environment. And I think a possible way to solve it is found actually way to express the transmission in the environment. That's all. Thank you.
Right, everyone, thank you very much for sharing your thoughts. Okay, so I'd like to open the panel to the questions from the audience.
So there's an interesting discussion about potential commercializability of your solutions. I want to suggest a different set of design constraints that I'd like you to react to. I'd like you to reflect on how sustainable the solutions, your prototypes, are in terms of their power requirements, in terms of life cycle implications of the technological solutions, and what you think we might do as a community to take your ideas and make the solutions more sustainable. You can start with the textiles folks, because I think you have the strongest answer.
Okay, I can start with that. So in terms of power, the sensors we talked about are variable resistors, so they're very, very low power.
But how low?
Oh, I mean, it depends on your circuit.
Yeah, well, I mean, if we're going to have millions of these deployed, it has to be extremely low power.
Okay, I can't quantify it for you. You can find it in the paper. But in terms of like long-term use, that's something I care a lot about. For e-textiles, we often have wear and tear challenges. The reality that we know from many other studies is that most of that wear and tear happens in laundering. And I've always argued that, solving the problem of making the sensor durable to laundering is the wrong problem to solve. We need to solve the problem of making the garment self-cleaning, and then we save all of the energy of laundering. So maybe that's a little far afield. I mean, there's sort of a lot to go between here and there. But I agree that, I think a lot of the vision of these kind of like sensor-enabled garments kind of relies on that. We have this trade-off between like redundancy and cost. So we can't use the current clothing model where we have different clothing every day if it's going to be so expensive to build these systems into everyday clothing. But I do think there's an awful lot to be said for changing that model so that we don't wear different clothing every day, and instead we have, one garment that changes its shape and its color and whatever, meets our aesthetic and sociocultural requirements for clothing while, also providing this background array of technology. Maybe I derailed this conversation.
Yeah, just as a counter to this point, so like since my sensor is batteryless, we've had some discussions on sustainability, and really it's not a question of low power. Like today, if you see the carbon footprint, it is dominated by embodied footprint and not operational. So if your sensor needs a battery, the battery is made, even if it's used for maybe 2 years, the battery is not going to decompose. So yeah, like I do feel there are some sustainable implications with our work, like because we show that, okay, you do not really need to use batteries while making sensors. You can piggyback on the operational footprint which already exists in networks, like there are wireless signals all over the place. You can harvest the tiny bit of energy from them and communicate and save on the embodied footprint. And I feel if we are able to make our sensors decomposable, so we've talked to a few companies as well in San Diego, from where I am, who are making these recyclable and reusable electronics. If the sensor becomes reusable and it's batteryless, it could be a good solution for the embodied footprint problem today.
That's great. However, in your solution, you have a very power-hungry RFID reader that needs to be deployed. So when we think about sustainability of our solutions, we need to think about the entire system. And how would you essentially reduce the power footprint of those readers as well?
Yeah, very good point. And this is something we've given it a thought already. So there are two things which we are doing right now. First could be like use an antenna array so that you can direct the power towards the RFID tag. That can greatly reduce the transmit power of RFID. The second thing is maybe look at more other ways of doing wireless, like perhaps like magnetism or acoustics, because they can do the same thing at a lower power. And these are the two things we are exploring to minimize even the operational footprint which will come. But to reiterate my point, from what we talk to many people, the AC power which you will require from the mains to transmit a signal versus putting a battery which will forever degrade the embodied footprint, it's not one versus the other. Like you really need to think the embodied footprint as well. Thank you.
So actually for our work, we didn't try to test the power consumption yet, but I believe because we already use some low power components like photodiode and LED, so I think our systems power consumption may be not very high. And for our work, I think the next step is to consider about how to reduce the power consumption of our algorithms for our models. Maybe we can try some tiny machine learning algorithms to reduce the cost of our algorithms so that it can be deployed to edge devices. So,
Okay, because I think this is a fascinating debate. You don't necessarily have to reduce computing if you're using a renewable source to power your computing?
No, wait.
No, I'm just saying. This conversation requires us to be much more educated and sophisticated in terms of understanding, well, what is the end goal? And it's not necessarily reduce power, it's reduce environmental impact. And that may not always mean the power needs to be reduced if you have responsible ways of generating the power.
So yeah, actually our hardware system is not a power hungry system. So for the power, it don't consume much power. So I'm not sure I answered your question.
No, you did. It's a conversation.
Okay, maybe we can have a conversation later. I will give others some opportunity to answer your question.
So for our work, I think, so as I mentioned before, Equinox has lower power consumption as compared to a lot of camera-based or other sensor-based solutions. So I think a large part of sustainability comes from like the system that Equinox is going to be integrated into, for example, VR headsets, and that might be like a future direction we could look into.
Well, I think you may be more interested in energy harvesting rather than the energy consuming. For the battery consuming in our system, I think that there are mainly two devices in our system: the wireless earphones and the smartphones. For the wireless earphones, the energy consuming is basically like something that you play music in your earphones, so it may last long. For the smartphone side, we haven't tested, but we may test it in our future work, but we assume that the energy consumed may be low. So yeah, that's my answer.
Is there is there anything to add from the virtual presenters?
Yes, may I speak? So regarding the energy consuming, we admit that in our work, microcam we did some tests. So we admit the micro does consuming more energy since it is inherent problem of turning on the camera, because we need to turn on the camera to collect some microscope image from the object that mobile phone plays on. But there is still some potential solutions, such as turning on the camera and some spatial time points, not always opening up, or reducing the resolution of the image, which will also help save some energy consuming. And I think more importantly, sustainable is definitely important, but I still would like to answer the question from a big angle, from the commercialized this perspective, because commercialize is always a balance point. So each solution always has some pros and cons, have some outstanding features. We always need to consider so many factors such as performance, energy, and cost. So I prefer to choose the cost issue in commercializer. For example, we use the built-in microscope of the mobile phone, but we also mentioned that in our paper that we can use some microscope clip it's always suitable for our method. So those clips are cheaper and more common in our daily life. So yeah, so that's my point. We always need to balance so many factors, not just the time consuming, power consuming. Yeah, thank you. That's all.
Faye, do you have anything to add? Maybe not? Okay. All right, so in favor of time, we are behind the schedule. So as long as there's no further question, and then I'd like to put this panel discussion to conclusion. So, okay, yeah. Thank you very much.
Thank you. Thank you, all of you.
Thank you, especially the virtual speakers. Thank you very much for staying at these late hours. And then, yeah, I hope you take a rest for the rest of the day.